before. But what do you have to add and subtract variables? Same base, same exponent. Same thing goes with radicals. Okay. Radicals are just bases and exponents. So you have to have the same simplified base to get this with the same exponents in order for things to work. So what we're going to do here is a lot of just rewrites. The first one's pretty easy. 7 times the quantity 6 1/5, or 6 1/5 plus 2 times 6 1/5. What do you get? 9 times 6 1/5. And you're done. It's just combining like terms. Yes?
I like this.
Okay? It's just like combining like terms. Now if I look at the next one,
I don't like this. It's like 3 to the 14.
Where's he going?
To get cold water. So I mentioned. Someone close it.
Close the door.
Do it.
Do it for 7. Oh my God. Oh my God. Too close.
you sent the girl wearing a dress to close the door?
Well, what would we didn't send her.
Hey, I think you're winning now. Get rid of that Olbert shit.
He's been waiting for the past 2.
It's gonna be like a street sweeper or something.
We have to start going off to the side.
Giant collage.
You can make it just
All right. So the other one here we have to get it to the same radical. What is the perfect cube root that's hiding within 16? 8. 8. You're looking for a cube, okay? So remember, you can rewrite these things as the cube root of 8 times the cube root of 2 minus the cube root of 2. What's the cube root of 8? 2. So this is, so it's 2 times the cube root of 2 minus, what's the coefficient in front of the cube root of 2 on the second part?
A negative.
Okay, you're right. It's a negative 1. So it's minus 1 of the cube root 2. So what's 2 cube root 2 minus a cube root 2? Very good. All right. As we start to get into this more and more, you're going to have to start looking for the perfect squares, perfect cubes, perfect fourth roots that might be hiding within the radicals. Yes, ma'am.
Like I get where you get like y8.
Is 4 a perfect cube? That's why. It's the same idea as when you're simplifying a radical. When you're simplifying radicals, you're looking for perfect squares. Four, 9, 16, 25. You're looking for those. But when you're doing the cube root, you're looking for a perfect. You're looking for the perfect cube.
So what's 4?
That was a good one.
So what's 4? That's it.
What?
And so on.
Yeah, you didn't put the congruent marks.
What?
You didn't put the congruent marks in the cube.
That's great. Shut up, Cody. What are you whining about? Oh, I did. There. How about that? Let's get to the crazy stuff.
No, this stuff isn't crazy.
This is where things can get a little nutty.
Party is nutty.
We're going to combine them together.
Watch.
But I have an awesome shortcut for this. No, it is not. Okay. But it has to deal with division. Okay. Right off the bat, when you have stuff like this, remember in the past we've talked about when you're simplifying anything, take care of the numbers first. What's the cube root of 125? So we know that cube root of 125, we're basically splitting this out into 2 parts. So you're getting 5 and then whatever this works out to be. Now, when you had, excuse me, when you have nth roots, you can always rewrite as exponents if you want. Another thing that I could say here is that this is y to the 6 over 3. You okay with that? Which is what? 2. Good. So the cube root of y to the 6 is y squared. And it's simplified. But what happens when this 6 is not a multiple of your nth root? What do you do? You wouldn't have to cry. Let's try something with...
I would. You just. Is this your
Just call
problem?
it
For example, if I just say the cube root of x to the 5th. Yes? No. Now, here's what I want to do. And when you simplified radicals in the past, what you were doing is you're looking for pairs of squares and whatnot. Like pulling out 2 2s, you can pull out 4, things like that. I'm looking for perfect cubes that to pull out of here, thinking in terms of division. It's a nice trick that I'm going to show you here. 3 goes into 5 how many times? Once. How many are left over? 2. So this is the same thing as writing it as cube root of x cubed times the cube root of x to the 5th. Squared. Do you guys agree on that?
Yeah.
Cube root of x cubed is
1.
x. Yeah, it's just x. And then you're left over with this. What I've done here is I'm going to eliminate this step by saying 3 goes into 5 how many times? Once. 1 comes out, 2 are left in.
Okay. I don't get it.
Okay?
I got it.
Let's try another one. We take the
Just leave it-
4th root.
Wait, you just leave it like that?
Yeah, you're done. 4th root of x to the 9th, y to the 15th, z to the 31st.
Jeez, Louise. I don't like that.
Doug, wait. I'm with Chris.
You
What?
want to do that.
No, buddy.
All right. 4 goes into 9 how many times?
Twice.
How many are left over?
1.
1. So that means that 2 x's, an x squared can come out, and 1 stays in. Okay? Notice I'm leaving a little bit of space, because that way I'm going to go pull things in and out here.
Oh, no. Wait, why is it that 2 go in front of, why is it the exponent is 2?
Because what this can be rewritten as is x to the 8th, x to the 1st. And if you do this with the exponent,
And how come you didn't put a 1 in front of the other? X, it was a 3 for the last part. Because it went into it once, so why is the exponent 3?
this part is here.
Oh.
It's the cube root of x squared.
Okay.
Okay. 4 goes into 15 how many times? 3. How many are left?
Okay, I didn't see. Oh, yes.
I know. Hold on. 4 goes into 15 how many times? Let's try this one more time here. 3. How many are left over?
3.
3 of them can come out. 3 stay in.
Ooh.
4 goes into 31 how many times?
7.
Oh, please.
7 of them can come out. How many stay in?
Ooh, okay.
And that's how you see
That's
it. It
it.
just looks more complicated.
I know, right?
So it's like,
It's a lot faster. And Abby, the problem you had yesterday where it was what? It was the 8th, it was 80, the 4th root of 80?
Mm-hmm.
What you were doing here is 80 can be rewritten as 16 times 5, where you have the 4th root, 16 is 2 to the 4th. 4 goes, how many of them can come out? 1 comes
Yeah.
out, and what are you left with? 4th root 5.
Yeah.
And that's the idea. As we're going to get into these more and more, we're going to take those larger numbered values and simplify them further. We didn't talk a lot about that yesterday. I wanted to wait a little bit into today. to show you these shortcuts with this division with the exponents. Anytime you get even numbers underneath the radical, see if you can write it as a base 2 combination. 80 was 16 times 5. 16 is 2 to the 4th. You're going to be able to use this trick of the division with the exponents to simplify your radicals. It's a great shortcut. Right? It's a really, really nice shortcut. Let's try it a little bit. What was it? Excuse me, I don't know why I'm yawning.
Excuse me.
Remember, this means the same thing as the square root of 9 u squared b to the 10th. What's the nth root here that you don't see? It's 2. What's the square root of 9? 2 goes into 2 how many times? 1 comes out. 2 goes into 10 how many times? 5 come out. Any left over? Done. Obviously, you could have done the same thing with the exponents. Distributing the power of half. 2 times a half is 1. 10 times a half is 5. It works the same way. I just want to show you that using the nth root, sometimes when you have a longer string of things, it's really fast just to use the division and then see if you have a leftover, any remainders. Why answer this without even trying? Oh, there's my pen cap. Oops. Looking all over for that. And I found it. Okay, let's see if we can make this difficult.
It's not. Kid.
Kid?
I don't know.
Hey, yo, kid.
I've like never seen his face because he faces the other way, so I don't know his Aw, he's trying to be friends.
No, I don't want to be his friend.
I'll take it. Can I have it?
No.
Thank you.
You okay?
I know.
What test?
Really?
Okay.
Now, if you had to take the biology of the Western civilization, that'd be kind of cool.
Turn around.
You're not gonna know like 70%.
You turn and suck because he's telling
He had 1-3 in my face and I was like,
Cool.
My real question.
Hey, that's good.
I was like, yes.
All right, a lot of times when you work with these things, again, you'll notice that you have the same nth roots, same bases. So I would work on the interior first. I'm going to get the 4th root of x to the 8th, which is what? X squared. Then it's x squared to the negative 2, which means it's 1 over x to the 4th then. Yeah, you're on your right track there, Cole. It'd be 1 over x squared squared, so it's x to the 4th. Start combining them all together.
No, I didn't know where you got x to the 8th.
Yeah.
I realized that you just added them.
Oh yeah, this is the
Yeah.
because they're in the same nth root. You can put them together.
Yeah.
All right, I'm done. I don't want any more.
Ooh, we're done.
Well, let's see. Let's do this then. What do we just do? 64. Why don't you guys try and get through 81, 57, 81? I'll give you the odds so you can double. You can check your answers.
Thanks.
All right.
I'm not doing it.
I only listen to one Christmas song.
Is this page?
57 to
I will. Yeah. I will.
What page is this?
It's the same page. It's the next page over. So whatever page that was, it was
12?
Sure.
Numbers what?
Do now.
Number 57.
Yeah, start on 57 and go through 81 and just go through the odds. Try to use some of those tricks of that division when you have the nth root. Use that as a really nice shortcut for a lot of those problems. Okay? You'll get it done before you get out of here. I did.
Yeah, play that same song.
Yes.